For section 8.5, we're going to learn these new formulas called the sum and difference formulas, very specifically for cosine, sine, and tangent. And before we dive into that, let's think about some things that we know how to do. So when we're evaluating or simplifying expressions involving trig functions, we can be asked to approximate or get an exact answer, okay? When you're asked to approximate, that means you're using the calculator and you're getting some wacky decimal, and then you typically round that to some pre-decided place value, okay? The other thing we're asked to do is find exact values of expressions, and that we do a lot, okay? And that's when you don't use your calculator. You use other tips and tricks and tools that we have in our toolbox. So some things that we use to find exact values of these expressions are to use just the definitions of trig functions. So we know, like SOHCAHTOA, for example, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse. We can use those definitions. We can also use the unit circle. We now know, hopefully we're getting much better at building the unit circle. So what the unit circle does is it highlights commonly used angles, and it gives us a tool to help us remember what the trig ratios are for these really commonly used angles, okay? We can also use identities. We know that if we have sine or cosine, if we use the reciprocal identities or the quotient identities, we can get cosecant, secant, tangent, and cotangent. We also, in the previous section, we're building all sorts of identities. So we can certainly use identities to get exact values of expressions. We can also use reference angles and coterminal angles, and we can even use the fact that trig functions are even and odd. So sometimes all of these things can work. Sometimes none of these things are going to be particularly easy. Okay. So that puts us in a situation with, okay, what next? All right. So imagine you have an expression that involves cosine, and it's cosine of some wacky angle, and you're like, there's nothing I can do with this besides type it into my calculator and see what I get. Well, now we're hopefully going to build a way that if you play your cards right, maybe you can get a better value for this than just some approximation on your calculator. So in the sum and difference formulas, you have to kind of imagine you have an angle that isn't working for you. But could that angle be rewritten as a sum or a difference? Okay, so imagine your angle isn't working, so you break it up into a sum, okay? And we're going to break this angle into two other angles. Let's call them alpha and beta. So alpha and beta are angles. And so if the angle you're given isn't working, and you can break it up into a sum, ideally breaking it up into a sum with angles that we do know, things that are like on the unit circle, then we have a workaround. Okay, so if you have cosine of alpha plus beta, so the sum of two different angles, you can take cosine of alpha times cosine of beta, and then you subtract, so we flip-flop our signs there, you subtract sine of alpha times sine of beta. Okay, so that works for when you have an angle that can be broken up into a sum, okay? Now, if you can't be broken into a sum, perhaps you could break it into a difference. So is there a way we could subtract two angles and get what we're starting with, okay? If so, if you can find a way to rewrite your angle as alpha minus beta, then we could take cosine alpha times cosine beta and add sine alpha, sine beta. Okay, so those are our formulas. Honestly, they're not really hard to use. The hardest part is remembering them. Okay, and the math department, they are definitely sticklers for memorizing formulas, so really start working and practicing your memorizing of these formulas, okay? Now, don't get too bent out of shape about where these formulas come from. We're not going to use class time to derive the formulas. Just know that at the end of the day, they come from a play on the distance formula and the unit circle, okay? So I have it kind of written out here, but let's recap a little bit. We use the formulas when we have an angle that is not on the unit circle, but can be expressed as the sum or difference of two angles that are on the unit circle. That's our ultimate goal. Create a sum or difference of angles that we do know, okay? And by breaking up the angle, we can use these formulas, or potentially, you can call them identities too. So these formulas or these identities to find the exact value of the function instead of an approximation on our calculator, okay? So that was a long, drawn out explanation. Hopefully when we look at sine and tangent, it'll go a little quicker. All right, for example one, it says, find the exact value of each of the following. Well, we start with part A, which is cosine of 105. 105, unfortunately, is not an angle on our unit circle. But is there a way that we could rewrite 105 as either a sum or a difference of angles that are on the unit circle? And what comes to mind for me right away is 60 plus 45 equals 105. So start thinking about the angles that are on the unit circle that we're familiar with, and see if there's a way that you can play on those either by adding or subtracting to get the angle that you're essentially given, that theta. Okay, so what I want to do is I want to rewrite cosine of 105 degrees as cosine of 60 degrees plus 45 degrees. So I have a sum here. So I want to go back and use the sum of angles formula, okay? Now you do, it's not my favorite thing, but you do need to work really hard on committing these to memory, okay? So this is going to equal cosine of alpha. Let's say 60 degrees is alpha and 45 degrees is beta. So this is going to equal cosine of 60 degrees times cosine of 45 degrees minus, we flip signs with cosine, minus sine of alpha, which is 60 degrees, times sine of beta, which is 45 degrees. And now these are all values that are on our unit circle. So we need to find the individual ratios. So there are 4 ratios that we need to find, and then we just have to do a little arithmetic. Okay. So on your unit circle, if you don't have it out, get it out unless you just have it completely committed to memory, which kudos if you do. Cosine of 60 degrees happens to be 1/2. So we're going to replace cosine of 60 with just 1/2. And then cosine of 45, that's the one everybody remembers. Everybody remembers sine and cosine of 45 degrees. That is root 2 over 2. And then from there, we want to subtract sine of 60 degrees. Well, sine of 60 degrees, hopefully you know, is root 3 over 2. And then sine of 45 degrees, again, that's the one everybody knows, that is root 2 over 2. And now we just want to use some basic, just play with numbers and simplify this. So if I have 1/2 times root 2 over 2, I can multiply the numerators and multiply the denominators. So 1 times root 2 is root 2, and 2 times 2 is 4. And then if I have root 3 times root 2, that's really just root 6. You can squish, if you have 2 square roots, you can squish them under one radical. So I'm going to subtract the square root of 6, and then I'm going to multiply the square root 3 times the square root 2, and then I'm also going to multiply the 2 times 2. So I'm going to be subtracting root 6 over 4. And we could write that as just root 2 minus root 6 over 4. And that is our exact value. It's not pretty, but it is exact, okay? So when we talk exact values, you're typically going to be thinking some radicals are going to be here. Now, just for the fun of it, let's go ahead and simplify this and just check it on the calculator. Let's see if square root 2 minus square root 6 over 4 is the same thing as cosine of 105. So let's jump over to the calculator really quick. We're not going to be able to do this for every problem just for the sake of time, but let's try it for this one. Okay, so first of all, make sure you're in degrees. I can see at the top of my calculator I'm not in degrees, so I need to change it. So I'm going to go to mode. I'm going to go down until I'm flashing on radians and then scoot over to degrees, hit enter. And what I want to check is cosine of 105. So we can see that cosine of 105 degrees is negative 0.2588190, blah, 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 blah. Okay, now we want to compare that to the answer we just got with the sum formula. So we're going to take the square root of 2. We're going to subtract the square root of 6, and we're going to divide everything by 4, and hopefully we get the same negative 0.25, blah, 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 blah. And we do. Now, please understand, if you were to write negative 0.2588, blah, blah, blah on your test, and you didn't show me the work, and you didn't show me the square root 2 minus square root 6 over 4, you would get no credit, okay? So you can use this to kind of just check to make sure your work is good, but you still have to show me the trigonometry and the algebra, okay? Let's go back to the worksheet. Let's look at another one. This time we're going to look at the formulas, but in reverse, okay? So for part B, we have cosine 40 times cosine 80 minus sine 40 times sine 80. Well, what in the world's going on there? So what we can see here is this very much looks like we're using a sum or difference formula involving cosine. We have the cosine of some angle times the cosine of some angle. So let's call 40 degrees alpha and 80 degrees beta. Okay, and then we have sine of that same alpha times sine of that same beta. So we definitely have something cosine-y, okay? And what you always want to do is look at the sign in the middle. Are we adding or are we subtracting? And be really careful because with cosine, we use like the opposite operation. So if we're dealing with a sum of angles, in the actual formula, we subtract. So this tells me we're looking at cosine of alpha plus beta, or cosine of 40 plus 80, which is cosine of 120, which is something that we know. Okay, so you can use these formulas backwards too. So cosine of 120, that is on our unit circle. So you can think of it in a couple of ways. So cosine of 120 is, well, it's maybe not quite there. Let me redraw that. It's higher. It's going to be more like right here. So we'll say this is our 120 degrees. Okay, but what is our cosine ratio? So if you don't have 120 degrees memorized, you could think, well, I've got this little reference angle down here. Okay, so this reference angle is 60 degrees. Okay, so what I could do is I could acknowledge that cosine of 120 degrees is going to equal plus or minus its reference angle. So cosine of whatever the reference angle is. We just have to acknowledge where 120 degrees lives. So 120 degrees lives in Q2, which is where cosine is going to be negative. So we would say, okay, cosine of 120 degrees is going to equal negative cosine of 60 degrees. And we already know cosine of 60. We literally did it in the previous example. So cosine of 60 is a half. So this is going to equal negative 1/2. So that is using the sum and difference formulas for cosine in the forward direction and then also in the backwards direction. So make sure you know how to, one, use them, but also recognize them and really start working on committing these to memory. I'll try to take class time as often as I can to help us work on memorizing. Okay. Now for example 2, it says find the exact value of the following. Okay. Well, we have cosine of pi over 2 minus theta. Well, that's just two angles. It's like we have kind of like an alpha and then we have minus a theta. So let's see what this could look like. Let me go back to the black pen. So we have essentially cosine of alpha minus beta, which we know is cosine alpha times cosine beta plus, remember we flip-flop signs here, and then we have plus sine alpha times sine beta. Well, in this case, we're treating alpha like it's going to be the pi over 2, and beta is going to be just the theta. So let's rewrite this formula, but let's plug in the actual angles we're working with. So we would end up with cosine of pi over 2 times cosine of theta plus sine of pi over 2 times sine of theta. And let's see what happens there. So we need to figure out what cosine and sine of pi over 2 are. And luckily that one's pretty easy. It's one of our quadrant angles. So we have basically this angle right here. So this is theta, or not theta, but it's pi over 2. We'll just call it pi over 2 instead of theta so we don't get confused. So we'll say this is pi over 2. And this occurs where we have the ordered pair 0, 1. So what is cosine of pi over 2 and what is sine of pi over 2? Well, cosine of pi over 2 is going to be that x-coordinate, so it's just 0. So we get 0 times cosine theta plus, well, sine is going to be the y-coordinate of this ordered pair. So sine of pi over 2 is 1, so we get 1 times sine of theta. Well, anytime you multiply by 0, you just get 0. So 0 times cosine theta is 0. And then anytime you multiply by 1, you just get whatever you multiply by. So 1 times sine of theta is sine of theta. So we can say that this is really just sine of theta. So simplified very nicely, okay? So that is the sum and difference formula for for cosine. In the next video, we will look at the sum and difference for sine, okay?